Lesson 2.12, Permutations. Our objective for this lesson is to be able to determine the number of permutations when selections are made from the same group of items, no item may be selected more than once, and the order of arrangement matters. Let's start by defining permutation. A permutation is an arrangement of all or part of a set of elements in a particular order. There's two things you need to know about permutations. First is that repetition is not allowed. This is just an arrangement of the elements of a set. You can't repeat the same element more than once. So the second thing you need to know is that order matters. And this doesn't have to be a numeric order necessarily. It could be, for example, let's say 4 friends are trying to form a band, and someone's going to play drums, and someone's going to play bass guitar, someone's going to play lead guitar, and someone's going to sing. Even though they're just one group, there's a bunch of different arrangements that you could make depending on who's playing what instrument. So each of those arrangements would be a permutation. Now, the other word we need to define for this lesson is factorial. Factorial is the product of an integer and all the positive integers below it. So you can see here n factorial is equal to n times n minus 1 times n minus 2 times etc. all the way down to 1. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. And this pattern of multiplying a number by each of the positive integers below it comes up so often in counting problems that we've given it its own name, factorial, and we've given it its own symbol, which is this exclamation point. All right, so now let's define a formula for finding the number of permutations possible. So the permutations formula is if we make R selections from a group of n items, the number of permutations is going to be given by this formula. So we write NPR, meaning the number of permutations from R selections taken out of n items is going to be equal to n factorial divided by n minus r factorial. Now this seems like a really complicated formula, but it really isn't. And let me show you where this formula comes from by doing our first example. So the first example says that there's a math club and there's 25 members in the math club, and they want to form a leadership group. Out of these 25 members, they're going to elect a president, a vice president, a secretary, and a treasurer. And we want to know how many different leadership groups are possible from these 25 members of the math club. And so what we're doing is we're trying to find permutations. It's a permutation because order matters, because there's a president, a vice president, a secretary, and a treasurer rather than just a group of 4 people. So this is a permutation. We're selecting 4 people out of a group of 25. And so our R is 4, the N is 25. So this is going to be 25 factorial divided by 25 minus 4 factorial. Let's just write that as 21 factorial. And so if we were to write this all out, 25 factorial is 25 times 24 times 23 times 22 times 21 times 20 times all the way down to 1. And that's going to be all over 21 factorial, which is 21 times 20 times ... all the way down to 1. And notice that this part, the 21 times 20 times 19 times 18, etc., is the same as the denominator here. So we can actually cancel these. These are going to divide to 1. And all we're going to be left with is 25 times 24 times 23 times 22. Now, another way of thinking about this that might be a little more intuitive than thinking about factorials and this formula and everything else is to just imagine that we've got 4 seats that we want to fill. We want to elect a president, a vice president, a secretary, and a treasurer. And now, how many different people can we elect to the position of president? Well, we can select any of the members of the math club. So that's 25. We have 25 options for that. Now, a person can't be president and vice president. So once we have selected a president, now we only have 24 people that can be vice president. So we have 24 options here. And then once we've filled those 2 seats, there's 23 options for the secretary. And there's going to be 22 options for the treasurer. And now we can just multiply these together. 25 times 24 times 23 times 22, which is the same thing we got up here from the formula. So 25 times 24 is 600. Times 23 is 13,800, times 22 is going to be 303,600. And there's our answer. That's how many different leadership groups we could make from the 25 members of our math club. Our second example says that a high school baseball team has 17 players on its roster. And we want to know how many different ways the coach can make a 9-player batting order. So first of all, this is a permutation. We know it's a permutation because order matters. We're not just selecting a group of 9 players. We're putting them in order. This person's going to bat first, this person's going to bat second, etc. So it's a permutation, and we're choosing 9 players out of the 17 players on the roster. And so our n is 17, the r is 9, and our formula is going to be 17 factorial divided by 17 minus 9 factorial. So that's 17 factorial divided by 17 minus 9 is 8 factorial. And another way of thinking about this would be this 17 factorial divided by 8 factorial is 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9. And you can see that if we're creating this batting order, we have 17 players to choose from for the first slot, then 16, 15, 14. So this would be the first slot, then second, third, fourth, fifth, sixth, seventh, eighth, and ninth. And so that's where those numbers come from. But now we have a choice. We can either plug this into our calculator, 17 factorial divided by 8 factorial, or we can plug all of these into our calculator. And you can see that this formula becomes more and more useful the more numbers we're dealing with. So let's go ahead and plug this into our calculator. I'm going to plug in 17 factorial. That's the exclamation point. It should be in exclamation point or x exclamation point on your calculator, divided by 8 factorial. And this is going to be equal to 8,821,612,800. So there's nearly 9 billion different ways that you can make a 9-person batting order out of a 17-player team. So that's permutations.